In this video, we are going to solve problem 13 on the sample midterm questions. We are given a total cost function, C of x, and we are asked how many units should we produce to minimize the average cost. Recall that the average cost is found by taking the cost function divided by the x number of units. So you are given a C of x. To find the average cost, you have to take C of x divided by x. And now you are looking for the mean value of the average cost because you are looking to minimize the average cost. Okay, so this problem is the local max and local mean problems from chapter 2, especially chapter 2.5. The first thing is we need to figure out what is the average cost function, and that could be found by taking C of x divided by x. We are given C of x, so to find the average cost, all you do now is you take this whole expression and divide by x. So 100x plus 100. The square root of x means x to the power of 1/2, so that I can simplify later on. The square root of the x to the third power, this is the same thing as x to the 3/2 power. 1/2 is the square root because we have the power of 3, that's why you have 3 here, and divide by 100. Now this is the C of x function. We divide by x so that we can get the average cost. Okay, so you can simplify this here. 100x, you can take the first term, divide by x. Okay, this is the average cost. And the next term, you can also take 1/2 and then divide by x. And then the last term, x to the 3/2 over 100 divided by x is the same thing as multiply by x at the bottom here. Okay, we need to simplify this expression. Now the 2x here, they cancel out, so you have 100 for the first term plus 100 for the second term. Now we have the same base x, so we go ahead and we take the subtraction of the two exponents. This is the first power, so 1/2 minus 1 give me minus 1/2. And again, this is 1, and you have x over 100. Okay, the x, the bases are the same, so you take 3/2 subtract 1. 3/2 subtract 1 is 1/2, and keep 100 at the bottom. We are just combining all the like term of the x together. Okay, so here is your expression of the average cost, and you are looking to minimize this value, this expression. Now, minimizing the average cost is the same thing as finding the local max and the local mean. And to find the local max and the local mean, the first thing is you need to find the critical points. To find the critical point, we first find the derivative and set it equal to 0 and solve for x. Okay, so the first step is you need to take a prior. Take the first derivative of the a of x, the average cost function. The derivative of a constant becomes 0. This is the power rule, right? So I bring down the minus 1/2 to 100. I bring down a minus 1/2, and then I subtract 1 from that. Minus 1/2 subtract 1, minus 3/2. Again, I bring the 1/2 down, 1/2 down, and I keep 100 down here, and then for the x, I subtract 1 from the exponent. So 1/2 subtract 1, that is minus 1/2. And we can also simplify this here. This is 50, x to the minus 3/2, and then this is 200 down here, x to the minus 1/2 power. After you take the derivative, we have to set it equal to 0 to find the critical point, because you are looking to find the local mean of the average cost function. Okay, so once we set it equal to 0, we have to solve for x. To solve for x, let's move this term to the right hand side. So I give this term on the left hand side, and then I add 50x to the minus 3/2 on both sides. Now let's combine all the numbers on one side and all the x on one side, or isolate the x variables. Okay, first thing, let me divide both sides by 50. Okay, divide by 50. When I divide by 50, I get x to the minus 3/2. So dividing by 50, all we do now is we take 200 multiply with 50, that is 10,000. So 1 over 10,000. And then x to the minus 1/2. Okay, so you are looking to solve for x, so you need to divide by x to the minus 1/2 on both sides. Now the x here, they cancel out, so all we get from the left side is 1 over 10,000 equal to, okay, we can combine the x together. This is the same basis x, so all we do now, we take the exponent, and then this is the division, so I subtract the exponent. So minus 3/2 minus of minus 1/2. Okay, so keep simplifying so I can solve for x. Okay, the 2 minus become plus, so minus 3/2 minus 3/2 plus 1/2. And we can see that this is 2, right? We can add the same 2's. We can keep the 2, we can add the minus 3 plus 1, that is minus 2 on the numerator. Okay, so 1 over 10,000 equal x to the minus 1, right? Because this is minus 2 over 2 is minus 1. And keep simplifying this expression, x to the minus 1 is same thing 1 over x. You are solving for x, so we go ahead and we flipping the fraction. 10,000, we are flipping the fractions on both sides, equal x. So this is the critical point. Okay, once you get the critical point, 10,000, we can do the testing. So let's plot 10,000 units here. Okay, to check if this is really a local mean value, we are looking to test one value on the left side of 10,000, one value on the right side of 10,000. So recall that the a prime function is right here. So let me rewrite as a prime of x. This is the average cost function. We are using the first derivative test to test for local mean here. Minus 50x to the minus 3/2. And then plus 1 over 200x to the minus 1/2 minus 1/2. Okay, so one value on the left side of 10,000, let's pick 9,000, just to make it simple, right? 9,000. Okay, so I plug in 9,000 to the place of x, a prime of 9,000. So anywhere I see x now becomes 9,000 minus 3/2, and then plus, okay, plus 1 over 200, and then 9,000 minus 1/2. Okay, let's use the calculator to make this calculations. 9,000 to the minus 3/2 multiply by minus 50, and then add to all of these, you get a negative value, right? Negative value. Okay, negative value means that if the first derivative is minus, your function is decreasing on the left side. And then if I use another value on the right side of 10,000, for example 10,500, so I plug in that to a priam, the same function here, I should get a positive value after using the calculator to do the testing. And I know that if my a priam is positive, then my function is increasing, the slope is going up. Okay, so we do have a local mean in this case, going down and going up. There should be a local mean, or at this number of units, 10,000 units, we are minimizing the average cost. Okay, so they ask you how many units should be produced to minimize the average cost. The answer is 10,000 units.